Hello all, welcome to my channel. In this video, I will explain what are the various NC words. These NC words are used to write a CNC program. So let's begin. What are NC words? NC stands for numerical control. So NC words are numerical control words. So before CNC machines were developed, the machine tools were controlled by hardwired NC by using NC words. So this NC words were used to control the numerical controlled machines which were hardwired. Hardwired in the sense cables were used to connect the machines to the controller and software was not used. A typical NC machine which uses paper tape in which NC words are punched is shown in the sketch. These NC words are used to give input or instructions to the NC machine tool. Later, when CNC machines were developed around 1950, the NC words were not changed and the use of the word NC still prevails. These NC words are as per the EIA standards, that is Electronic Industries Association standards. Why do we need the NC words? So NC words are the selected English alphabets that are used along with numbers to provide the machining information to the CNC machine. The words used are N, T, S, X, Y, Z, G, M, S, and so on. These words along with numbers provide some information to the CNC machine. And the CNC machines are operated as per the program, which appears something like this. The program contains block of instructions. So these are the blocks of instruction. The first block is N40, G00, X20, Y30, EOB. Then the second block starts with N50 and the third block starts with N60. Each block of instruction contains some NC words followed by numericals, as it is seen here. So these are NC words G, X, S, T, and they are followed by some numbers. These NC words gives instruction to the machine to work as per the requirement of the programmer. As the machine don't understand English language, the instructions like spindle start, coolant on, change the tool, feed rate is this much, or call the subroutine are given to the NC machine or now the CNC machine by using these NC words. So let's see what are the various NC words. The first NC word is the sequence number. It is called as N words. The next NC word is preparatory function, also called as G words. Then the miscellaneous functions, which is called as M words. Then the coordinates functions called as X, Y, and Z words. Then the feed function called as F word. Then the spindle speed function called as S words. Then the tool selection functions called as T words. And finally, we have the eighth NC word as end of block words called as EOB words. Let us understand how these words are used in CNC program one by one. The first NC word is sequence number and it comes first in the sequence when we write a program. The first word in every block is the sequence number, that is N. The sequence number is preceded by letter N and is written as N001, N002, N003, and so on. The program is executed from the lowest block number to the highest block number, that is 1, then 2, and 3. And this NC N words are similar to the sequence number or serial number. The programmer generally proceeds block number in the steps of 5 or 10 so as to insert the automatically omitted block later on, like N05, N10, N15. So instead of writing N1, N2, N3, programmer generally use N5, then second block is N10, third block is N15. In case if the programmer misses some block, then the block can be inserted here as N06, or otherwise the entire program has to be re-sequenced. Some programmer tends to write N10, N20, N30, and so on. This type of sequence number also helps the programmer to add the blocks if the program has to be edited or if there is change in the workpiece, a little change which needs to be incorporated in the program, that can be easily done by adding few more blocks in between. Although this is not compulsory, a programmer can follow N1, N2, N3, but this is suggested. The sequence number is used to identify a particular block. So if I say N05 means that particular block of instruction can be understood by N05. Then comes the preparatory functions or G words. These words are used to make the MCU, that is machine control unit, ready for operation. These are called as the instructions. Preparatory functions or G words are basically the instructions which are given to the machines on how to operate the machine or how to move the tool, how to move the workpiece. Sample instructions are, it is giving instruction to the tool to go fast. It is telling the machine that the feed rate of the tool should be this much. The G code will tell that the dimensions are in mm or inches, like this. The preparatory codes are represented by an alphabet G followed by two digits number ranging from 00 to 99. For example, G00, G01, G21 are the G words. The G words usually follow the N words. First comes in the sequence is N word, then G word or any other word. The N20, G28, U, V, W or the coordinate words, then N30, G40, and so on. The G codes are modal or non-modal. I have made a separate video for this modal and non-modal code. I will share the link in the description. You can watch the video to understand what are modal and non-modal codes. Then comes the miscellaneous functions or M words. So as the name suggests, these are the miscellaneous functions, that is the supporting functions. So they are here in the supporting role and they are auxiliary functions that may or may not be needed directly when the machining is on. For example, tool change or stop the spindle. These or coolant on. These are the miscellaneous functions which are supporting the G words is machining operation. The miscellaneous codes are represented by an alphabet M followed by two-digit number ranging from 00 to 99, similar to G codes. So here we have M05, M30 or M98. The meaning of these G codes and M codes are explained in a separate video. Again, the link of that video will be shared in the description. The M words are usually written towards the end of the block or follow N word when written alone. For example, N30, M08. So this is the only word, M word written. So it can come immediately after the N word. But if we are writing G word and M word, we generally follow the sequence as N word, G word, and M word. Although it is not at all compulsory to write G code first and M code last, but this is the sequence which is followed while writing the program. Then comes the coordinate words or the dimension words or X, Y, and Z words. These words specify the final position of the tool or the workpiece in that particular block of instruction. It means these words provide the destination of the tool to the machine control unit. The coordinate words are written in alphabet like X, Y, Z, I, J, K, U, V, W, or sometimes A, B, or C. And similar to G code or M code, they are also followed by numbers specifying the distance, like X 20, Y 30, or Z 10, or it can also be written as I 0 and J minus 10. Some machines take distance input in decimal numerical system only, and some takes in decimal numerical system also. The coordinate words are represented by above alphabet followed by numerical with or without decimal like this: x 2.0, x 95, or some cases z 0.0. Now in CNC lathe machine, there are only two linear axes, that is x-axis and z-axis. The x-axis is perpendicular to the spindle axis and z-axis is along the spindle axis. So if we see here, the spindle is here, this is the workpiece, and this is the z-axis and this is the x-axis. Again, I have made a separate video to understand the axis in CNC machine. I will share the link of that video in the description. In CNC machine, there are three linear axes, x, y, and z. X and y are the horizontal axis, while z is the vertical axis. Here, the workpiece in case of milling machine is a flat workpiece, whereas the workpiece in the lathe machine is a cylindrical workpiece. To specify the angular position about this linear axis, sometimes I, J, and K axis are used. To specify secondary linear motion parallel to x, y, and z axis, U, V, and W words are sometimes used. One thing to note here is the z axis is the spindle axis, so it is horizontal in case of lathe machine, and as it is spindle axis, it is vertical in the case of milling machine. Next is the feed function. Feed is important because it determines the time required for machining the workpiece. The feed function is used to specify the feed rate in the machining operation. That is, it specifies the rate of movement of tool with respect to the workpiece. Feed in the lathe machine is towards the spindle during machining. It can be observed here, the feed is towards the spindle. That is the only feed given in the lathe machine. In case of milling machine, the feed is provided in along two axes, that is along y direction and along x direction. So we can have feed in x direction, we can have feed in y direction. And when the tool moves in downward direction, it is called as depth of cut. The feed functions are represented by an alphabet F followed by numerals with G code like this, F90. And when it is written with G code, it is written as G01, X20, that is XYZ word, and then the feed function or F. The feed rate is expressed either in mm per minute or in mm per revolution. So when the feed rate is expressed in mm per minute or mm per revolution, the controller has to understand what are the units revolution. The feed rate is in mm per revolution. Then it may be expressed like this: G01, Y30, feed 90. And when the feed rate is in mm per revolution, then it may be expressed as F0.2. Let us understand the meaning of this two feed rate, F90 and F0.2. Now, F90 is the feed rate in mm per minute. It means that in 1 minute, the tool would move to a distance of 90 mm. So it is possible that the tool will move a linear distance of 90 mm in 1 minute. Whereas mm per revolution, where feed is 0.2, means in one revolution, the spindle, the tool will move to a distance of 0.2 mm. So it is possible to move to a distance of 0.2, 0.3, 0.4 mm only in one spindle revolution. It is not possible to move a linear distance of 90 mm in one revolution. And it will be a too small distance to move to 0.2 mm when the feed is in mm per minute. By looking at the feed, one can understand whether it is specified in mm per minute or it is specified in mm per revolution. The feed rate depends upon the combination of tool and the workpiece material. Feed rate is to be specified with certain G codes only, that is G01, G02, and G03. With G01, G02, G03, feed rate is to be specified in the block of instruction of this G code like this. G01, then XY watts, and then the feed function F90, and then end of block, or G02, X25, Y30, R10, and then F0.2. 01, 02, 03. These are the three G codes with which the tool is moving, whereas G00 is another G word with which the tool is moving. But with G01, we don't have to specify the feed rate because G01, 02, 03 are in the control of the programmer, whereas G00 is not in the control of the programmer, because G00 is the maximum feed rate, which is decided by the manufacturer, who calculates it as maximum feed rate is equal to RPM of servo motor into pitch of the ball screw, which gives us 3000 RPM into 3 pitch as 9000 mm per minute as the maximum feed rate. That's why with G01, G02 or 03, which are interpolation, that is G01 is linear interpolation, that is linear movement of the tool. G03 and G02 are the circular interpolation or the circular movement of the tool that needs the feed to be specified. If the feed rate is specified in mm per minute, then it is informed to the controller by providing the code G94, which is generally specified in the first few blocks of the instructions. If the feed rate is specified in mm per revolution, then it is informed to the controller by providing the code G95. This code is also provided generally in the initial blocks of the program. The code G94 or G95 has to be specified only once in the program and it has not to be repeated again and again. In order to convert the feed in mm per minute from mm per revolution, the following formula is used. In mm per minute is required, provided is mm per revolution. So multiply mm per revolution by the spindle RPM. That is, if 0.2 mm per revolution is the speed and 900 is the spindle RPM, then the speed in mm per minute is 180 mm per minute. Then comes the spindle speed function or S word. The spindle speed functions specify the revolution with which the spindle rotates in CNC lathe and tool rotates in the CNC milling. Means the speed function in case of lathe is for the spindle, whereas the speed function in case of milling is for the tool. The spindle speed is specified by alphabet S, and it is followed by some value which is in number, and it denotes revolutions per minute like S1200. That is, spindle speed is 1200 revolutions per minute. If the machine runs at 1200 RPM, then the speed will be specified as S1200. Important point to remember here is spindle speed is not the cutting speed. The spindle speed is calculated by the formula V equal to pi dn upon 1000, where V is the cutting speed in meter per minute. Cutting speed depends upon the tool workpiece material. In this formula, N is the spindle speed and D is the tool diameter if the speed is calculated for milling machine, and D is the workpiece diameter if the speed is to be calculated for lathe machine. The cutting speed depends upon the combination of tool and workpiece material, and the speed for different combination is provided in the charts or standard data books. Then comes the tool selection function or T word. The tool selection function or T word is used to specify a particular tool needed to perform the specific operation. For this purpose, T words are represented by alphabet T followed by 4 digits. Like this, T0403. Out of this 4 digits, the first 2 digits denote the tool position in the turret or tool position in the automatic tool changer ATC. Here, 4 is the tool position which is in the turret. So T04. T04. The next 2 digit denotes the location where the tool geometry offset is stored. Here, this is the place where the offset of tool geometry is stored. Here, in this case, as it is stored in 03, this is the X offset and this value is the Z offset. There is no radius offset. That's why 03. So 0403. T0403 means tool located in position number 4 of the turret or magazine, and its offset value is stored in 03 position like this. So the 04 indicates the position of the tool in the turret or the automatic tool changer, and 03 indicates the position of the tool offset in the machine control unit. This tool selection function or T word is always specified with miscellaneous functions M06 when it is written in the program, something like this. Here, N25 is the block number, M06 means change the tool, and the new tool to be put in the position is T01, which is located in position number 1 in the turret, and its offset value is stored in 02. The T word is needed only for machines with automatic tool changer or tool turret. In case where there is automatic tool changer or tool turret is not available, in those machines, tool change cannot be happened when the machine is going on and has to be changed manually by the operator by stopping the operations. The automatic tool changer keeps the record of which tool is kept at what location, and then that can be used to write here as 01, which is indicated here, 01. For example, if tool number 06 is drilling tool, then the command will prompt T06, that is tool number 06, which is kept in the automatic tool changer or the turret. The last block of instruction, the last NC word is end of block function or EOB word. The end of block word is used to inform the controller that the block ends and its execution can be done now. That's why EOB comes at the end of the block. When the controller reads the block, it reads like this N10, G90, G21, and it will search for EOB, end of block. As it searches and finds the end of block, then the particular block can be executed. If it searches and it does not find end of block, then the block of instruction will not be arranged and some error will be prompted in the program. Some controller use LF, that is line finish, or semicolon, or the enter symbol to indicate EOB, like this. If any one signal should only be used, any of this end of block or enter or semicolon should be used in the program, and a programmer should not switch from EOB to LF to semicolon because it depends on the controller whether it should use EOB or LF or semicolon or enter symbol. The next video will be on NC programming format. Thanks for watching the video. If you have liked the video, then press the like button. Subscribe to my channel if you are new to my channel, and share the videos with your friends. Thanks for watching.